Today we are going to see question involving initial rate method. It's another way used to determine. This is used to determine the order of reaction. Okay, initial rate method is used to determine order of reaction. Before this, we use integrated rate law. We use the graphical method, linear graph, and then we also find from the unit of the rate constant. Now we have another method called initial rate method to determine order. For that, we look at question 2, Kumbe 8. Okay, consider the reaction at 55 degrees Celsius. A series of experiments carried out with the following result. Okay, so you look at the table. You have a few columns and few rows over there. First we look at the column. They give the initial concentration of two reacting species, CH3 3CBr and OH negative. Dia berikan kedua-dua kepekatan. Kemudian row terakhir, baris terakhir, dia berikan rate mole per liter per second. Okay, and then we go to the column. Subsequent column is experiment 1, experiment 2, experiment 3, experiment 4 and experiment 5. Okay, so the first question is to determine order of reaction with respect to the reacting species. Both reacting species, kita kena cari dia punya tertib tindak balas atau order of reaction. Okey, bila kita nak cari satu species punya order of reaction, satu lagi species dia punya concentration, kepekatan kena malar ataupun constant, right? So in this case, step pertama adalah kita kena tulis general rate law. So kita kata generally rate equals to K CH33 CBr, katakan power M, kemudian OH negative power N. Okay, generally lah. This is generally. So then we have to take two experiment yang mana concentration OH negative itu constant. Okay, so in this case kita cari dua eksperimen yang concentration OH negative itu constant. Okay, kita cari. Okay, saya jumpa eksperimen 1 dan 2, juga eksperimen 1 dan 3 lah, di mana concentration OH negative itu constant. So katakan saya pilih eksperimen 2 dan eksperimen 1. So saya akan tulis eksperimen 2 divide by eksperimen 1. Okay, I write like that. Kemudian saya tulislah dia punya rate law. Untuk eksperimen 2, mula-mula kita tulis secara umum rate equals to K CH3 3CBr M and then OH negative N divide. So here also rate, here also CH3 3CBr power M OH negative power N. Okay, we do like this. Then kita substitute semua nilai dalam semua formula inilah. Okay, rate for experiment 2 is given as 0.010. Rate for experiment 1 is given as 0.0050. Okay, kemudian kita ganti. Okay, kita tak tahu. Okay, concentration of CH3CCBr dalam eksperimen 2 adalah 1.0 power M. And then for OH negative eksperimen 2 0.050 power N divide by K. And then concentration of CH3CBr for experiment 1 mana ni eksperimen 1? 0.50 sorry. 0.50 power M. Okay. And then for experiment 2, for experiment 1, I think I seen wrongly. Kejap. Experiment 1 is 0.10, and then the K is, this is experiment 2 0.10 betul, kemudian untuk CH3 1.0 pun betul, kemudian itu 0.50 betul lah. Okay, Kemudian eksperimen 1 0.0050 betul, K betul. Kemudian ini, oh, I think I've seen eksperimen 1 OH minus tu betul. Ini 0. Sorry saya salah tengok. Ini yang saya salah tengok Kejap. Okay. Okay, so this is experiment 1, 0.50 power m, and this is 0.050 power n. Okay, now correct lah. Okay, so we get like this. Now, step seterusnya adalah kita kena tengok mana yang kita boleh cancel. Which one we can cancel. Okay, alright, K can be cancelled. Kemudian 0.05n pun boleh cancel. So tinggal yang dua lagi lah. So you take calculator and cuba kira. Okay, kita ambil calculator, kita kira 0.1 divide by 0.05. So sini saya dapat 2. 1 divide by 0.5 pun saya dapat 2 power m. That means m sama dengan 1. Kita kata first order respect to CH3 3CBr. Okay guys, dapat tak? Tengok dulu, kalau ada tak faham sila tanya. Macam mana, dapat tak jawapan? Boleh dengar ke? Jamboard tu dapat tak jawapan dia? Halo, halo. Dapat Dapat M sama dengan 1 dapat tak?
Dapat.
Okay, good. Okay, kita proceed dengan untuk cari N Kita cari N pula. Okay, kita cari N. Slide yang kedua Slide yang kedua, kalau nak cari N, eksperimen mana bahagi dengan eksperimen mana untuk cari N, negeri N tu? Which experiment divide by which experiment? Any idea? Boleh cadangkan. Kuat sikit, tak dengar lah. Experiment 4 and 5. Okay, kita cuba Experiment 5 divide by experiment 4. Okay. So I straight substitute the value So start with experiment 5, 0.010 sama dengan ini, divide lah. Experiment 4 is 0.010. Okay. And then K, don't forget the K. So the first concentration will be 1.0 power m. That is for experiment 5 Experiment 5. And then this is 0.20 power n. Experiment 5 also. Bottom here, experiment 4. Experiment 4, this is 1.0 as well. 1.0 power m. And this is 0.10 power n. Okay. Then as usual, we see what are the things can be cancelled off. You can cancel the K, right? You can cancel the 1 power m, also can. And then that remaining is the calculation part, right? So this is 1 equals to 0.1 divide 0.2 divided by 0.1 is 2 power n. Okay, so n must be 0. Is it correct? Am I correct mathematically? N equals 0. Betul ke? Dapat ke zero order yang lain? Dapat Okay, so we have to do the conclusion here. Kita kena buat conclusion Rate equals to K CH3 3 CBR OH negative So ini zero order. Yang tadi first order. So power zero dia akan jadi satu lah. So jawapan akhir rate equals to K CH3 3 CBR and this is the rate law. Dapat ke? Cuba tengok. Dapat tak rate law? So ini adalah jawapan B Tadi kita buat adalah untuk A. Sekarang kita buat untuk B. Boleh tanya kalau ada apa-apa yang tak faham ke any problem? Ada yang tak faham ke, nak tanya ke? Understand? Okay. I hope the rest also. Okay, good. Faham tu okay lah, good Okay. Alright, finally, next slide. Kita nak kira C That is the rate constant lah. We want to calculate the rate constant. So, we take from the general formula just now. So, K equals to rate divided by CH3 3 CBR. Okay. Now you can substitute any experiment. You boleh gunakan mana-mana eksperimen you nak gunakan. Let's say I use experiment 3, 0.015. I'm using experiment 3. Example lah. 0.015 divided by concentration 1.5. Okay. So, cuba kita kira. So, is 0.01. Now we have to find the unit of K. This is molar per second. This is molar. Right? So cancel off the molar. Answer is per second. Dapat ke 0.01 per second? Can get or not, guys? 0.01 second. Can, okay, can is good. Okay, can is good. All right, moving into the next question. Before that, I want to ask again about initial rate method. I want to tell